In this video, we will be discussing on how to derive maximum intensity duration relationship for a storm event. This derivation can be completed solely using rainfall mass curve. Let's say we have a mass curve plotted by station X for the past 96 hours. Throughout this period, 3 storm events took place. Let's focus on the first event, which started from the beginning and lasted for 40 hours. To derive the maximum intensity duration relationship for the storm, we need various time steps that represent storm duration. For our case, the storm duration is 40 hours, and we can use time steps equal to the multiples of 4 hours. In other words, we will be adopting storm durations of 4, 8, 12, and so on until 40 hours. Then, let's extract the mass curve data and put them in tabulated form. To cover all the time steps, we should tabulate the cumulative rainfall depth for every 4 hours. First, we will append a column to the right side of our table. This column represents the 4-hour duration. To fill this column, we need to calculate the incremental rainfall depth for every 4 hours. For instance, for the 4th hour, the incremental depth under 4-hour duration equals to 2 mm minus 0, resulting in 2 mm. The process continues until we fill this column completely. Among the incremental depth value, we will highlight the maximum one, namely 80 mm. We will deal with it afterwards. The process is repeated for the remaining time steps. At this point, we successfully obtained the maximum depth for each of these time steps. Now, let's move the highlighted maximum rainfall depth with corresponding time step to another table for clearer view. At this point, we also plot the maximum depth duration curve using the data we have now. To determine the maximum intensity for each of these time steps, we simply divide each of these maximum depths with their time steps. Then, we should be able to plot a curve of maximum intensity against duration. Note that it is common for us to express the duration in minutes. Further to this result, we may try to fit the curve using the Sherman formula. In this expression, A, B, and C are the fitting constants we obtain from regression. One of the simplest ways to do this is by using Microsoft Excel. First, we plot the graph of maximum intensity against duration using scatter plot. Then, we simply add a trend line to the chart. Based on the structure of our general expression, we should be using power trend line. We can then ask Excel to show the trend line equation and R-squared value for better illustration. Finally, let's compare the trendline equation to the general form of the expression. From here, we know the values of coefficient A, B, and C are 0, 0.404, and 45.225 respectively. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.